All right, in this video, we are going to work through the following problem. The instructions say use identities to fully simplify the expression. The expression that we have is cosecant of x plus cosine of x times the cotangent of the opposite of x. So when I look at this expression, the first thing I notice is this opposite of x in here. I know the even odd identities will allow me to rewrite that expression so that the inside is just x instead of the opposite of x. So if I look at those even odd identities, I can see I've got the cotangent of the opposite of x here. That is equal to the opposite of cotangent of x. So using that identity, this can, oops, I'm in the wrong tab. So using that identity, this can be rewritten as cotangent of, or the opposite of the cotangent of x. Here I put this in parentheses because otherwise it looks like that's subtraction when this is just multiplication. All right, so I've got cosecant x plus cotangent x times minus cotangent x. So I can rewrite that as minus cosine of x times cotangent of x. Right, that would be equivalent because this is essentially positive 1 cosine x times negative 1 cotangent x, right? So that'll be positive 1 times a negative 1 will be a negative 1. Then I have cosine x times cotangent x, like so. Okay. Okay, so next up, right, is I want to look at reducing some of these other trig functions. Cosine, there's really nothing I can do with that to make that any simpler, right? But cotangent and cosecant, looking at the identities, I can see that cotangent is cosine over sine, right? And cosecant is 1 over sine. So those are the two identities that I want to use here. All right, so I'm going to write cosecant as 1 over sine x and I'm going to write cotangent as cosine x over sine x, like so. All right, so now you can see that introduces some fractions in there. I can rewrite this cosine as being over 1 if I like, right? And so then to carry out that multiplication over here, I have two fractions that are being multiplied, right? And so I need to do that first. So when I do that on top, I'll have to multiply these two fractions, to just multiply the numerators and then multiply the denominators, right? And so on the top, I have cosine times cosine. So that is going to be cosine squared. And on the bottom, I have 1 times sine x. That's going to be sine x, all right? So that is simpler than what I started with. All right, now what I have here are two fractions that are being subtracted from each other, okay? And they both have a common denominator. See how they have a common denominator of sine x, and that's great because to combine or add or subtract, right, two fractions that have a common denominator, I just add or subtract the tops, in this case subtract, right? So that's going to be 1 minus cosine squared. And on the bottom, right, that'll just be sine x. Like so, okay? All right, so that is simpler, right? Now I have it as one big fraction, okay? And so now looking at some things that I can do. Sine x, again, that's as simple as it's going to get. It's nothing I can really do there. So on top, though, I have this 1 minus cosine squared. So if I go back to my identities list, right, I can see that has basically 2 of the 3 parts of this identity, this Pythagorean identity. Sine squared plus cosine squared equals 1. Okay? So what I can do is, if I take this identity and rearrange it a little bit, it will again be an identity. So if I start with the identity and now off to the side, I'm just going to write this other identity over here, sine squared plus cosine squared x equals 1. So if I subtract cosine squared x from both sides over here, right, then I get sine squared x equals 1 minus cosine squared. Like so, okay? So again, this is off to the side. I'm trying to simplify the top of this expression 1 minus cosine squared, and I can see, hey, that looks, you know, similar to this, but it's not quite. You can rearrange this. If it's always true that sine squared plus cosine squared equals 1, well, then it's always true that, you know, sine squared equals 1 minus cosine squared as well. And so what I can do now is, because 1 minus cosine squared is equal to sine squared, then I can replace the 1 minus cosine squared on the top of the fraction with sine squared. Okay? And so that's what I've got. So again, that looks a little simpler than what I've started with there. It also has the advantage that it leads me to another simplification, right? I have sine squared x over sine x. So if you think about what sine x is, or sine squared x is, that's just sine x times sine x, right, is what that is. And on the bottom, I have sine x. All right, so if you write it out like this, you can easily see, hey, I have a common factor of sine x between the numerator and the denominator of this fraction, right? So I can cancel that out. So sine x goes into itself once up here, it goes into itself once down here, right? And so on the top, I have sine x times 1, which is just sine x. On the bottom, I have a 1. So that's what it simplifies to. And then anything over a 1 is itself. So this whole thing, right, simplifies down to sine x. Okay? Again, so this expression, right, is just sine x. Again, it's for every x for which this expression is defined, right? Sometimes cotangent is undefined, so obviously, you know, it won't be exactly the same. But wherever this expression is defined, right, it is for every x, right, it is exactly equal to sine x. Okay. All right, and that is it on this example.